Welcome to You Code Things. Today we're building a simple snake game in Rust. We'll be composing together some incredible libraries or crates and using documentation to quickly understand how to use them. At the end of this video, documentation should be far less scary and you'll be empowered to build your own applications on top of Rust's crate ecosystem. We'll be building a simplified snake game using a 2D graphics toolkit called Piston. Here's my finished game with my complete code in the description. I'll get you as far as controlling a snake on the screen and show you every concept needed to build your own take on the snake game. So why the Piston framework? Honestly, I chose Piston because it was the first on the Are We Game Yet list, and I've never used it. Of course, the first thing you do when learning someone's crate is look at the examples. So let's start by building our project. Set up your project with cargo new snake game bin. Copy paste those dependencies. We're going to install the dependencies by using cargo build. This fetches all the dependencies and compiles them. Now we have all our dependencies, we can generate documentation. This lets you search docs across the entire project. Generate docs with cargo doc using an open flag to have the documentation open. Set these aside for later. This example creates a rotating red square on a green background. We're making a snake game out of squares, so we can use this. Copy paste those external crates. This reminds Rust of those dependencies. Notice that Piston 2D Graphics is just called graphics here. This is because Piston 2D Graphics is the package name, while the library is called graphics. Just declaring external dependencies doesn't let you use their stuff. We need to use them. Note the asterisks. This horrid thing dumps everything in its namespace into your namespace. This makes it hard to follow where things come from. But we'll do it anyway because it's following the example. The general design of our app is like so. We have a blob of data or struct that represents our game. This structure has a render method that draws it to the window. Everything in the game, like key presses or snake collisions, occur separate from the rendering and just update this blob of data. Then of course, the blob of data is told to render and you get animations of a snake running around. The first baby step is to make the window. In the main function, we create an OpenGL variable and a gluten window. You know how to use this static method because of the example code. But what if you didn't? Jump into those generated docs and search Windows setting. Top results, baby! We can see that title has generic type T and must be able to turn into a string. There is also size of generic type S, must convert into a size. Make sense? Of course not! What is size? Clicking on size reveals that it can be any of these. Add a window title and hard-code a width and a height. At the moment, the window will open and instantly close because the program runs to the end of the main function and exits. Enter the event loop. A little more copy-paster. Of course, always copy-paste responsibly. And so I ask you, what does events.next do? You're getting good at this. As you can see, event is an enum, which just means there are different representations. And all these traits are different events. Notice they all add methods to the event enum, allowing you to essentially check the type of an event you've received, like this renderArgs method. This if statement says, if the event is a render event, then we'll do something. If the event is not a render event, the renderArg method returns none, and the if statement fails to pattern match. We have a struct or object called game. It takes a GL graphics. This is what draws stuff in the window. And we're adding a render method. Notice in Rust, it works like Python. The first argument to the method is the instance calling the method. And because it's Rust, we can dictate how a method takes the instance. For our render method, we'll take a mutable reference to self, because drawing to the screen is mutation. Render will also take a reference to the renderArgs event. Are you again wondering what renderArgs is? Okay, that was the last time. Use graphics. Gives us access to graphics in this scope. I want a green background, but make any color you want. A color is 4 fields, red, green, blue, and opacity. Each must be between 0 and 1. Now let's use our graphics renderer to draw. It needs a viewport, which we can get from the renderer event, and a closure. This is a function that is called by draw. It passes a context and itself as the two arguments. Use the clear function in the graphics library, and you have the instructions for a colored window. Initialize the game struct in the main function, and call that render method. Let's draw a square! This will become our snake. Add a snake field to the game object, and let's create a very simple snake struct. Give it X and Y positions, and a render function. It takes in the GL graphics as an argument, as well as the render event, so it can draw itself. The code for rendering a square is very similar to the game render method. We're just passing through what we need. We need to call this method after clearing the background in the game render method. Don't forget to initiate that snake in the game instance. So let's take a quick breather before we complete the snake game. We've essentially covered everything you need to make a snake game. The keyboard events are just another kind of event. You get them the same way you get render events. There's also an update event for updating your game. For example, moving the snake. And the snake is just a list of squares instead of one square. So let's speed up. Give our snake direction. Modify the snake so it sees the game as a grid. And update the render function so it multiplies the X and Y to the correct place on the screen. For the snake, top left is 0, 0, and the bottom right is 9, 9, if we're using a 10 by 10 grid. This becomes pixels by multiplying the width of the cell. Now we need the snake to move whenever an update method is called. Let's create the method. The game object calls update on the snake. Update moves the snake in the direction that it's facing. We can move the snake by pattern matching on the direction field and changing the cell. Whoa, that was fast. After a quick search on the events, I found a method UPS or updates per second, which we'll set to 8 updates per second. Better. Now let's change the direction. Capture the button press events. Let's create a pressed method on game and use pattern matching to turn the snake. I've added guards to prevent the snake from being able to reverse direction, although there is a small bug here which I'll let you find. The compiler will yell at us for trying to compare these directions because we haven't implemented the concept of equality. Oh, that was pretty easy, actually. Let's make this a snake. You can do this however you like. I'm using linked list from the standard library. Update the snake to be a linked list full of coordinate pairs for each body segment. Now we need to update our snake's movement code and render code. To move, we clone a new head of the snake or front of the list. We must clone it or we'll be mutating an existing body part. Then update the X and Y for that new segment based on the direction and push it back on the front. Pop off the end to make the snake's tail shorten, and then we have to render this. Essentially do everything the same, but for each body segment of the snake. We map over the body segments and turn them into a vector of squares. Draw each square in that vector using for each. And we need to fix our snake instance in the main function too. Build a linked list from a vector using the fromIter method. You'll need to import the fromIter trait. I'm going to let you implement the rest of the game now, with my solution in the video description. Be creative and add any features you want. Make the snake shoot, or add sounds, or add enemies. When you finish the snake game with your own creative twist, make sure you tweet it at me. I'll show creative entries in my next couple videos. Like, subscribe, and tell me in the comments, what do you want to see more of from this channel? Next video, I might finally do a tutorial on the ownership